lots of performance improvements and metrics, and also experimentations around how can we load things the fastest we can possibly do for front-end modules. And I'm going to just walk through some of the things that we found out. So my name is Vinicius. I'm from the shipping module, and we're building the most amazing shipping service ever here for Klarna. And so for performance improvements, one of the first things that you want to do is metrics. You want to gather metrics. You want to understand how you're doing on performance. And then from there on, you're going to do experiments on how you're going to load things and how you're going to do better for the parts where you're slow. And it's like a repeating cycle. It's never ending, really. So this is actually a pretty accurate representation of how it looks like in real life. So performance should actually be an everyday task. It should start from when the project actually starts, because you have to think through how things are going to be developed, how you're going to decouple things so you can load them later, or what parts of your code can be or should be loaded asynchronously. But it's about how you think about it on an everyday, and how you measure it, and how you have a history that you can understand how you're doing on performance. You don't just simply tackle it one day and then you're done, but it's a continuous thing. And the reason why we do this is because it doesn't matter really, like, the most amazing features that we built if in the end our users are left hanging, just waiting on a white page for 20, 15 seconds. This doesn't really bring them any value. It doesn't matter how awesome the features we're building if you're just like waiting forever and ever. And one interesting factor is that nowadays the web actually is quite bad on mobile. It's slow. Overall, it's a very big bundles of JavaScript where most of it is never used, or it takes forever to parse and render, or it's just slow overall. And this is from a pretty good article actually by Adios Money, the state of the JavaScript in 2018, and it depicts on how the whole market, how the internet overall looks like on a mobile phone. But it takes on a CNN website. So on a high-end device, say, I don't know, your Mac or your latest version of iPhone, it's going to run just fine normally. But when you take on an average phone, a Motorola G5 or whatever is the latest version of that, it adds up actually 13 seconds. That is just for scripting. It's like, we're not even talking about downloading it. We're just talking like it already is there, the bundle, and it's taking another 13 seconds just to go through that bundle, initiate the events on the event loop and everything. So it's pretty taxing. Not only the amount of JavaScript that you write, but how you write JavaScript is also pretty taxing on mobile phones. So, and in the end, all the features that you build, all the cool things that you build, if you do not test and do not continuously improve for every single user, they're just going to be grumpy. They're not going to like your product. In the end, it doesn't matter. So the reason why we do this continuously, the reason why we keep on stressing, is that we want to make interactions for our users smooth, not slow and broken. So in the end, you have a few ways how you can keep a track of how you monitor and measure performance. For the shipping module, we have introduced Lighthouse on our CI. And we also have a few Webpack plugins that can help us keep a track on bundle. I'm going to be running through a few of the ways that we keep track of bundle, but I'm going to also focus on a bit on Lighthouse. So Lighthouse is a tool by Google. It's open source, and nowadays it's available in many different forms. One of them is a Node CLI, and it also has a J. Travis ready-made, I think, plugin that you can just hook into your CI. And it is available in each and every Chrome out there since a few versions back. But Lighthouse is actually a brilliant tool to help you gather insight from your project. So what it does is that it runs your code, your website, the URL, and you can tell it to emulate a mobile device, and you can control how much CPU throttling you want to throw in there. And it also can emulate different connectivity situations. So for the shipping module, we have introduced Lighthouse into our Jenkins pipeline. And what it does is that every time we have a PR, Lighthouse is going to run on that PR. So the PR itself will be built and then be made available on a specific URL. And then Lighthouse is going to be run on that URL and is going to gather detailed information about loading times, how many scripts we are sending down the pipe, what are the render blocking scripts, and actually a lot more. Lighthouse even gathers SEO and even gathers accessibility information, which is great. And it is going to compare that against what we have in our latest release. So this gives us insight into how is the health check of that PR. How are we doing for the specific codes that we're doing? Sometimes Lighthouse brings us some interesting results. This is actually a pretty interesting regression on one of the PRs that I was taking for performance improvements, mind you. And one of the reasons why it was doing so bad on time to interactive and main thread workdown is that I was just trying to load too many things at the same time. It's not immediate. It's like it doesn't become super easy to find out these kind of things by just if you don't have anything to measure and push things to master and release. And without this kind of metrics, you're never going to know that you're actually introducing regression, even though you could think that you're doing the best thing ever for the users. So based on that, we just broke down scripts in priorities and then load them accordingly. And later on, we're going to have a look on how that's going to look like. And also, Lighthouse help us with historic data. So every time we merge into master, we tag for a release. Lighthouse report is going to be saved into our Git environment. So if we want to understand how are we doing compared to a certain version, we can just go to stash and hook it up on the Lighthouse report, compare the two versions, either the JSON or HTML file, which is pretty good. It gives us insight on how are we doing historically. But after you gathered your data, and mind you, Lighthouse, whenever you do run Lighthouse and whenever you have it, the data that it makes available for you, what it's doing is that it's not actually throttling the hardware where it's on the CLI, but what it does is it gathers the data, and is going to have a extrapolation on top based on what you passed. So if, say, you want to see how you're doing on an average mobile phone, it's going to extrapolate that data to what it could be on a mobile phone processor. Same with the Ethernet speeds. But it does give you insight on what can you investigate, and it gives you pretty detailed insight on scripts as well. So based on that, once you have the data, you're going to hook into something like the performance tab on Google Chrome, or Firefox might have something pretty similar. Actually, it does. And you are going to be doing some performance tooling around it. So you're going to have sessions, I don't know, loading times, if you want to fix loading times. And it does gather a lot of data for you, and it gives you amount of time spent on scripting, parsing, loading, layouting. So based on different things that you want to tackle, you can have more deep insight with this tool. And you also have a pretty brilliant tool that not many people are aware of. I don't know if all of you know that Chrome has a code coverage tool, and it is, if I'm not mistaken, the only browser that does, built in, but it's pretty brilliant. So in here, I'm showing how the code coverage tool looks like in Chrome. So I'm first going to load, I'm going to throttle the network and CPU for how it does it look like on a mobile phone. And when you do that in Chrome, it actually is doing hardware throttling and network throttling, so it's pretty accurate data. And I'm going to hook it up with the code coverage tool and reload the page. So what the code coverage tool does is, as long as it's recording, it's going to give you actual real-time statistics on how much of your code are you using. So if you want to not only see like on-load code coverage, which is very useful for when you want to see what code splitting are, where you're going to code split. But if you want to see like, okay, I want to see how much of the code is used after I trigger certain features, it keeps on recording that and it keeps on giving you the data. So there is a chunk that I found out on Instagram that's never used, is a module. You can see by the .exports. Probably some deep inside module. I don't know. It could be something for browser support, which they could detect it and avoid shipping. And then I navigate over to another profile page and see if that changes. It changes slightly, but that part never changes. So this is actually like really good, insightful data on how are you doing overall on code usage. Because we should not really send down the line code that are not going to be used. Based on that, once you understood your code coverage, once you got your metrics, once you have everything down, it's time to do, actual tooling around how you're going to be introducing performance improvements. So you have a few ways that you can tackle performance improvements. One of which is just compressing your assets. This is pretty standard, but out there in the internet, people still don't get it sometimes. You have to compress images and, well, SVGs and so JavaScript and CSS. But I'm going to also be talking about a few of those that we actually used on our module to avoid making whoever consumes those modules lower, which is code splitting and prefetching. So code splitting is actually pretty simple and standard. You just use a async import where it's actually supported on latest ECMAScript. And the brightness is actually a bit bad, but I don't know if you can read that. But what it's doing is it's just using a synchronous import, to make your bundle be shipped, not built statically. When Webpack goes through that, or whatever bundler you have, if supports asynchronous import, it's gonna defer this to a different chunk, and it's gonna ship that chunk down the line whenever you actually require this bundle. So Webpack has this built in, and it works pretty well, even on IE11. So it's an actual piece of our code that we use to avoid shipping the dialogues part. So dialogues normally are just like subflows that you have. It could be either a settings panel, or in this case, our flows have dialogues to enter data. But the thing is that users might never click on those. So if you ship this down the line, you're making users pay parsing times and loading times. And especially on mobile, this escalates actually quite quickly. It becomes very taxing very, very fast. And especially when you use Redux, which in this case is a few selectors for the Redux, and we also use a few middlewares, it just accumulates because it's hooked into the event loop, and Redux is just a pub sub, so you're doing more work than you actually should be doing if you have those selectors in place. So this way, what we did is just avoiding any parts of the dialogues on the Redux and on the rendering part to be shipped and parsed on the browser. It's only used when it's actually needed. So once you have the code split part, it's time for you to decide on what should you load as soon as your bundle arrives. So that PR that I had, the screenshot that I had from the PR, was actually involved with this chunk, where I was just trying to load, like, oh yeah, okay, I have my dialogues that I want to load right after I finish loading the main bundle. I have this part and that part, and I was just loading everything at once. But what ends up happening is that you're just really hogging the CPU with scripts and network with scripts to download and parse and put in memory, where you actually don't want to. You want to focus on rendering the initial bundle that just arrived. So this bit of script, hopefully you can read most of it, is just organizing scripts by priorities. So how do you get to those priorities? Well, it's again a matter of experimentation and also understanding the flows of your application. But what this does is we have a few high priority scripts and medium priority scripts and low priority scripts alongside with the main bundle, where we're gonna fetch on the next slide. This is even harder to read, I imagine. H8 command option. Oh no, but that's actually an image. It's not code. Yeah, so it's a bit unfortunate that the brightness is a bit too big. Huh? Sure. Or on the other. There you go. He's in the speaker right here. All right, this is actually a lot better. So let's go back to full screen. There we go. All right, so, well, probably now you can read this better as well. So I'm going to be just spending a bit of time again. So again, this is just the code splitting part, standard async imports. And also what you can notice is that we do the imports first, and then we do the await later, because what we want is that we want to ship the scripts down the line in parallel fashion. We don't want to just import async await every single script, because what ends up happening is just you're going to wait per script. So we want to async parallel that. And that is the prefetching bit. Again, just a series of async imports with medium, high, and low prior. So also you can notice that the dialog, I don't want to just ship every single dialog at the same time. I ship the main bit of the dialog, and then we wait for the rest of the dialog's flows, the content that is rendering the dialog. So for the prefetching, that is an app shell, as we know out there. Here at Klarna, some of the designers are talking about this as a skeleton UI, but it's the same pattern. What it does is that it serves the user with something just to keep them entertained, like a loader, like a more glorified loader, like Facebook does, for instance. So this is pretty much zero dependency. Like it only has, in this case, it only has React, but since we're going to be loaded as a module, React is already in memory. And what it does is just very basic HTML and JavaScript and CSS to just build a very simple loader, glorified loader in that matter. And on component mount, we're gonna send down the main and the high prior at the same time in parallel, but we only wait for the main bundle to arrive. Once the main bundle arrived, we start rendering, and then we schedule the other low and mid prior scripts to be rendered on the next request animation frame. So this allows us to have the benefits of shipping the smallest possible chunk down the pipe, but also avoid endless loading times once the user starts interacting. Because if you just code split, that's what happens. Like we actually had a previous brief state where we didn't have this, and the actual flows got significantly worse, of course, because if you don't code split at all, yes, it takes a lot of time for your bundle to ship down the line, but once it arrived, it has everything, so the user is pretty, well, if the user is still there, he's going to be pretty happy because he's going to be using everything. But if you just code split, you're going to have a very fast initial rendering, but the rest of the flows are going to be significantly slower. So you have to understand which parts of your application are needed, what are the flows, how do you going to build meaningful chunks, and prioritize those chunks so they can be sent down the wire in a more meaningful fashion. So this is a video where I have sent, like, where is the mouse? There you go. This is a video where I have a demo for the 3 different stages that where we were on no code splitting at all, code splitting without prefetching, and also we have code splitting with the prefetching. And I hope it isn't too loud. Oh yeah, control option, command 8. There you go. Let me just see how loud this is gonna be. And I hope you brought your rock bands. Right. So as you can notice, it's quite significant. The more throttling you put, the more significant the results get. So the center column was like everything, always bells and whistles, the prefetching, preloading, all in place. And by the time the user finished interacting with them, with the middle column, like the other ones would start rendering and being available. So putting all those techniques together leads you to a much better user experience. And this is, we already been there. Thank you. There you go. So this is just about how important it is to have performance as a continuous metric and a continuous governance in every single project that we have here, because without the metrics, without experimentation, we wouldn't be able to arrive to those significant results at the end. We would be pretty slow. So we all have to make a deal here and agree that we care about performance. I think all of us do. We want our products to be successful and make users happy. And this is an everyday task, and it's very hard to achieve, and it's not always super easy or super obvious, but it ultimately pays off, and every single user gets happier. So that's pretty much it for the talk. And I usually hang in the front-end channel. So for whatever discussions about performance, JavaScript, and whatnot, feel free to just reach us out there. And thank you. So I guess we have time for some Q&A.
Yeah, thanks for this tech talk. And I have a question about prefetching. You've made a request animation frame to get mid and low priority bundles. Why did you use request animation frame instead of, I think, set timeout or set interval? No, just set timeout. Isn't some performance better to do this, or it's just the way you did it?
It's just a matter of browser availability. So I could have used the request idle CPU callback. That would have actually significantly improved in some manners on at least parsing time, for instance, where you can just delay the loading of the low priority scripts to a time where the browser is just done with the current chunks, and you have some idle callback. But then I would have to, polyfill that somehow. Mostly, what people do is request animation frame is not available. So I just decided that request animation frame would be good enough because the size of our module is not that big, and those scripts are together. Like they don't ship that much code, with a few exceptions on a few different modules dependencies that we have. So it just was not worth it, the extra effort.
Okay. So I guess there's a lot of cost actually to implementing this in like your day-to-day processes, right? You have to keep an eye out for this aspect and the other aspect. Did you start like manually doing this, or is this like frameworkable somehow? Can you somehow invent a way of like this not impacting the day-to-day work all that much, but still having all the benefits?
Yeah, well, kind of. So one of the reasons why we could code-split so easily is that we have a general decoupling of our components. So components for us, we have them mostly just the functions and higher order components. And even on the component itself, we split completely what is rendered from behavior. Like the behavior of the component is even on a separate file, and just a series of functions that we compose and export the component as just this composable functions. So for us to code split, it just means like, yeah, this function is going to be shipped much later. So the more coupling you have in your code, the harder it is to actually code split. It's the same reason why, for instance, people overall rely way too much on tree shaking, for instance. But tree shaking is going to be just as good as your code is decoupled, because if your code is decoupled, then tree shaking doesn't do much for you. Webpack just cannot really coerce if that bit or this bit is going to be eventually called or not. Then you actually, like by importing just one function, you can eventually import like 50% of the module.
But did you end up with like downloading 1 million files for all the 1 million components?
No. So what you have is so that's where experimentation is very keen. That's where you have to really like use the performance tab on Chrome or Firefox, because you want meaningful chunks. Because HTTP requests, especially HTTPS requests, are very costly. HTTPS requests on slow networks can take up to almost a second just for the handshake alone. So what you want is you want meaningful chunks. So you want to gather insight into what is the meaningful chunk that you can build. And even within the meaningful chunk, you can have some like, okay, this is actually deferred to much later use. Then yes, I can also do this asynchronously, even lazily. So you don't have to prefetch like a million different chunks at the same time. But yeah, it's a matter of experimentation and just understanding how it's in.
Oh, thanks.
What's up, Benny? Experimenting, right? These things versus server-side rendering.
Sure. Well, server-side rendering gives you a good first paint metric, but if you still have 2 megabytes to serve down the wire, you have 1 second first paint or even less, but then you have 10, 15, 20 seconds of nothing, just a static page. And that hurts even more the user expectation. So I guess there's one question over there. Oh! We just discovered that this thing actually can be disassembled. You can shout at me. Oh, that's actually a really good question. So, yeah, so for the streaming is the question was how do we handle chunking load failure? How is that handled? Well, our module has so our module is using React 16, and with React 16 we have these error boundaries. So for the error boundary, what we have is if anything fail, we don't ultimately fail the whole application. Of course, if the main bundle fails to load, then sorry, you have to reload the page. But let's say a certain dialog failed to load. What we do is that we render a specific dialog for error, and we allow the user to retry. So that's in place as well. So, but it is also like you can try. You have always to, because it is just promises, right? So if it is just promises, if you have a catch, you can implement a retry that easily. So it also is good for you to let the user know. So we have this in place. So if it does fail, we automatically just let like upstream know. So we show a dialog or a toast saying, yeah, sorry, we failed loading this dialog, and please retry. We're going to retry. And then, yeah, after certain amounts of retry, it just automatically fails. Yeah, okay, so the question is about HTTP2 and imagine H2 push. So we didn't do HTTP2 experimentations for the push. But it's also like it could be even better because what HTTP2 push allows you is to because right on the script what I did is it also has to be shipped down the line, parsed, then evaluated and all of this, and it will take some extra time for it eventually to start downloading and prioritizing so the browser knows what to do. So if you use HTTP2 push, you can spare some good milliseconds and yeah, be eventually faster.
It works? Yeah, awesome.
Right.
Did you play around with service workers as well?
That's next on our list to allow prioritizing cache as well, to use service workers. And also like since we now have this historic data with Lighthouse, and I actually can just show you how it looks like, perhaps the full report. So if I escape here, and if I don't embarrass myself too much, live demos are always dangerous, even though it's static. So for instance, I'm just grabbing here one of the build hash, and this is what it looks like. There we go. This is one of the Lighthouse reports, and we have it, as I said, we have per version. So this is a previous versions that we had, and it has everything here that we can possibly want. Like how much time did it take to load, and be interactive on a mobile phone on the 3G network. This is like unused JavaScript, but this is because mostly we prefetch the bundles. So what Chrome sees is just unused JavaScript, and that's actually okay on this matter because you can see that those are just chunks. So for the unused JavaScript, you can see that it's mostly just chunks, and that's perfectly fine in this case. But if I saw my main bundle having a high unused chunk, that would be an alarm for me. And what we're gonna do actually is just for historical purposes, we're gonna have this in a dashboard, for instance, to accompany, like to follow very closely on how did we do for each release. And this with this HTML, we also generate a JSON report. It's just the raw data of the HTML, and it's quite huge. So it has tons of data for us to crunch and try to understand things. And this gives us very good insight and historical purposes for our application.
So, and then I'm also curious, like, about those chunks you're splitting. Did you in any way force, like, for example, node modules to be more heavily cached? Because we are working in-store and we kind of focusing on performance a lot as well. But I noticed, like, in the main chunk, the biggest dependencies are React and Bubble UI. So it would be nice that those won't be updated very much, ideally. So it would be great if you could just get those out and serve those, even servers worker, cache that shit. And then I think we have a massive performance game, but did you play around with stuff like that?
Well, in our case, since we're integrated into KCO, we can't do much about dependencies itself. But if you are standalone, what you can do is have those dependencies into a vendor file, JS, where you're just going to cache it forever, for instance, and that's not going to be served. And you can even have your service worker to fingerprint that as well and just don't mind it at all.
Interesting.
Yeah.
Thanks.
All right. I guess that's it then. Thank you all.